Howdy folks, Mr. K here with a lesson on polarity and how it relates to solutions. So, first we got to talk about what polarity is. So we talked about how atoms have two parts. They have a positive nucleus in the center surrounded by an electron cloud with negative charges. Well, these negative charges aren't always evenly distributed, especially in the case of compounds. Sometimes one side of the compound will hold more electrons or the negative charged particles than the other side will. Salts and water are examples of compounds where this occurs, because the chlorine in salt tends to grab all the electrons and pull them through towards it. In fact, most nonmetals in a compound are negative. They pull all those negative electrons towards them, making them a negative side. In water, the oxygen is very, very negative. It's a strong nonmetal. It pulls all the electrons to one side, making one side negative and then the other side positive. So compounds can act like tiny magnets. Just like how a magnet has a north side and a south side, compounds are the same way, and the rules still apply. Opposites attract and likes repel. So just how the north side and the south side line up with each other and the north-north and south-south repel, positive and negative sides line up in within compounds just like the magnets. So what we call this is polarity. When things have a positive and negative side, they have a polarity, and they're called polar substances. So let's say we have sodium chloride crystals, salt crystals. Well, those are the blue positive side, which are the sodiums, and the larger green are the negative side. The chlorines are pulling all the electrons. When you dissolve them in water, you find that the water molecules, which also, remember, have that negative side and positive side, they line up. So notice how the negatives and positives line up with each other. So the chlorides get surrounded by the positive sides of the water, and the positive sodium get surrounded by the negative sides of water. This is called polarity in solutions. When the positive and negative sides of compounds line up with their opposites, just like the magnets line up with their opposites. The rule is, and it affects polarity, that things that are polar dissolve in things that are polar. Things that are not polar dissolve in things that are not polar. Polar things, so classic example of polar things. Water is polar. Salt is polar. Things that are not polar. Examples of nonpolar things would be soap. Soap is not polar. And oil. Oil is not polar. The golden rule, like dissolves like. Polar dissolves polar. That's why salt dissolves in water so well. They're both polar. Soap and oil dissolve together really well because they're both nonpolar. Water and oil, though, do not dissolve with each other because one is polar and the other is not polar. They're not like. Water in particular is very important. It's called the universal solvent because water is very polar and its structure allows things to be easily dissolved, making water the most important substance of all, especially for life. We cannot exist without water because of water's polar nature. If you remember when I talked about solutions, I pointed out with these solutions that every single one of them contains water. And the water in them is always acting as a solvent. Water is the universal solvent because of its polarity. Because of its polarity and structure, water has a very high melting and boiling point. It expands upon freezing. It dissolves in a variety of substance easily. Polarity, key word. Water is special because it has really good polarity. Okay, folks, things to remember from this video is what polarity is and why water is important. What thing about water gives it its special properties, and what is the word? Remember, universal solvent. Water is a universal solvent because of polarity. I will see you in class.